Dear student, welcome to the lecture. In the previous lesson, lesson 1.4, the previous video, we were introduced to the concept of trigonometric functions. We started with the right triangle definition of those functions as the ratios of the sides, and then we took off with the unit circle definitions and mostly worked on that. Okay. Looks like we are back to right triangle trigonometry. So this is a short lesson. We are particularly focusing on trigonometry in the right angled triangles. Okay, right triangle is right angle triangle. And we will basically be looking at some standard angle situations and non-standard angle situations in the right triangle. What standard, non-standard? The right angle is the right angle, the standard one in all of them. But the other two acute angles, right, could be like standard pair, like 30-degree and 60-degree, or 45 and 45, or it could be some other, random um, angle. Okay. So in each case, how to solve, how to evaluate different trigonometric functions, and how to evaluate the inverse values of some functions. We will look at that on this video. Okay, let me begin here. So this is all just practice problems. Okay, there is no theory here. We are solving the right triangle. Okay, so say you have that triangle whose sides are 1 square root of 3 as the legs, and the hypotenuse is 2. You should know that we don't need to be given all three. Okay, if any two of these are given, you can compute the third one by using the Pythagoras theorem. Okay, just keep that in mind. As a illustration of what I was saying, let me write here. If we square the root 3 and if we square 1, that will be 3 plus 1, 4, which is the hypotenuse squared. Okay, that should always be the case for the right triangle. I might have removed the angle from here because it was very complicated to edit that in the Microsoft Word. Okay, that's the right angle there. And the angle alpha is over here. Okay, now for this angle alpha, cos alpha equals root 3 over 2 adjacent over hypotenuse. Then you remember that root 3 over 2 from the trig butterfly I was talking about in the previous lesson. Okay, where does it occur? The x coordinate root 3 over 2 occurs at 30 degrees. I'm going with degrees because here, the unit we are using is degrees. It appears, from the blank. Sorry. So root 3 over 2 is cos 30 degrees. Therefore, it's not like we cancel the cos. We look at the equivalence. Cos alpha equals cos 30 degree. So alpha is 30 degrees. Okay, don't cancel. That's not what we're doing here. Just equate them. The same question, similar question can be rephrased like this. Instead of asking you to, um, find alpha from sine alpha, it could be given as sine inverse of that. Okay, that's a notation. So evaluating sine inverse of root 2 over 2 is basically asking this question. Okay, if sine alpha equals root 2 over 2, then alpha equals blank. That question is basically the one that you are seeing here. Okay, how? When you say if sine alpha is root 2 over 2, then alpha, it's almost as if, if you take the sine to the other side, we get the inverse function. Remember the concept of inverse functions from pre-calc or college algebra? So the inverse of this sine function would be the sine inverse function, right? Alpha will be the inverse of that. So we would say alpha is sine inverse of root 2 over 2. That is the idea. Okay. So that means if I am going to, let me bring it to left side here. Okay. Now if I were to evaluate this sine inverse root 2 over 2, I am basically looking at this equation, right? Sine alpha equals root 2 over 2. And then I'm realizing sine alpha equals root 2 over 2. Looks like this is the unit circle with radius 1. So the sides are root 2 over 2 and root 2 over 2. Recall when that happens? At 45 degrees. Okay. Doesn't say which unit, so I'm going to write in radians. That's 45 degrees. 5 over 4. Okay. So this expression, sine inverse root 2 over 2 here is the alpha, the angle. Okay. So I will highlight and write that here is an angle. You might want to remember that. Sine inverse, or similarly, any trigonometric function inverse something is an angle. Okay. The trig function maps angle to numbers. The inverse, trig inverse will map the number to angle, right? Root 2 over 2 to an angle pi over 4 by that inverse function sine inverse. Okay. Now, both the first problems are related to standard angles, right? The standard values, standard angles. What if you are given sine inverse of 2 over 5? Now, there is no standard angle where, the sides are of length 2 and 5. Hypotenuse is length 5. The opposite side is 2 in ratio. Okay, 2:5 ratio. What do we do? Use calculator. Okay, and you ensure that your calculator is in degree mode. Okay, we have talked about that before also. So let me take you to the calculator on my iPad. Do the same thing in your. Okay, where do I see? Is there a thing like second function here or not? We are in the scientific form. I see sine cos tan, but do I see sine inverse? The one at the bottom are sine hyperbolic. Let me see. Math notes. I mean, I should go back to the calculator. What was the other option? Oh, okay. Was there a second function option somewhere? Oh, yeah. Yeah, sorry. Second function, and now in the bottom row, I see that here, okay, sine inverse 2 divided by 5. What did I say? Yeah, we should be in the degree mode by default. Okay. I have talked about this, earlier. If you are not sure about the mode, just 1 second, I'm going to show you. Okay. I could evaluate sine inverse 0, which I know. Okay, sine 0 is 0. So sine inverse of 0 should be 0. So yes, so we are in the right mode. Okay. So what you do now, sine inverse of 2 divided by, my bad, 0 does not help. I should have taken sine inverse of half. Sine 30 degree is 1 over 2. Okay, so sine inverse of half should be 30 degrees. Okay, so we are in the degree mode. Okay, and let's go back. Sine inverse 2 divided by 5. What did I do here? 2 divided by 5. 23.578. 23.578. Doesn't say how many decimals. So I'm just going to write 3 decimals. Okay. Find alpha given cos alpha equals 0.923. You do it. It's the same process. Now alpha will be cos inverse of 0.923. This time let's find that in radians. Okay. Nobody said which unit, so you choose yours. For that I'm going to go to the radian mode and say cos inverse of 0.923. Okay. Now this is radian angles. Okay. 0.395 approximately, because we are doing approximations. Okay. I'm using the approximation symbol, not equal to symbol, radians. Okay. If you don't write anything, it is understood to be radians. But if you want to clarify, you can do that. Okay. Now, in the next set of questions, I said, solve the right triangle in addition. Okay. So what it means is you are asked to evaluate, all these sine alpha, cos alpha for that triangle. But we said, you could do that without doing any extra work on the triangle, just by trigonometric formulas. But we are, actually in addition, I said, but you do that first, it will be easier to write these ratios afterwards. Maybe for one of them, I will illustrate to you how you could find all these ratios without completely solving the triangle. But first, for the first one, let us solve the triangle and write the ratios. Okay. And later you can choose, what you like. Now, solving the triangle means what? Solving the triangle means finding all 6 things of the triangle, by the way. Okay. Solving means finding the values of all 3 sides and all 3 angles. That is the meaning of solving a triangle. Okay. So here it will be the third side here. Okay. We call it x. That x will be under root 5 square minus 2 square. Pythagoras theorem. Okay. The hypotenuse is 5. So that is under root 25 minus 4. That is under root 21. Okay. That is x. And alpha would be, you can take any one of them. Okay. Will be sine inverse of 2 over 5. And you can put that in a calculator. In fact, we did that a second ago, so I'm going to write that 23.578 degrees. So I'm going with equality for now because we'll be solving the triangle. Okay. Okay. And next, the remaining angle is beta. And you can solve that more easily because the sum of the acute angles has to be 90 degrees, right? So that angle beta there will be 90 minus alpha because the other angle is 90 degrees. And if you do 90 minus 23.578, you are going to get 66, 56 or 60, 66.578. So it will be 422. I'm not wrong. Okay. You can punch that on a calculator. Okay. So that is solving the triangle. Now we have all 6 things, 3 angles and 3 sides of the triangle. Okay, let's do the next part, which is all these ratios. Sine alpha opposite over hypotenuse. Cos alpha would be adjacent over hypotenuse, and that would be x, which is under root 21 or 5, tan alpha would be opposite over adjacent. Okay, now of course you would like to rationalize that by multiplying by under root 21, both numerator and denominator. So that is 2 root 21 over 20. Okay. Now, what about the other ratios? They will be reciprocals, right? Cosec alpha will be 5 over 2. Sec alpha will be 5 over under root 21. So that will be 5 under root 21 over 21. And cot alpha would be, I'll take this one for reciprocally, okay? Under root 21 over 2. Right? Same here. You have to find this sine alpha and sine beta, these things, okay? So I was saying we could do this without solving the triangle. Okay, no, not this problem. Maybe the next one. Okay, this time we will find the hypotenuse because that is the easiest way to do. If you have to find sine and cos, we need the hypotenuse, right? Okay, that is 8. That is 12. So what is the hypotenuse? That is 2 times 4, 2 times. Okay, these are not regular values, so you have to compute. The hypotenuse here, h will be, let me calculate it on the side first and then bring it here. Under root 8 square plus 12 square. And you can use the calculator for that. I'm going to simply take 4 out of it. So it will be 3 square plus 2 square. If you are interested, okay. 12 is 4 times 3. 8 is 4 times 2. So 4 square can be factored out and then it comes out of the root sign as 4. And you are left with 3 square and 2 square, okay, which will be 9 plus 4, 13. So that is 4 under root 13. Okay, even if you use calculator, make sure your calculator gives you answer in the radical form like that. The scientific calculator can do that. Okay, don't write in decimals, that is important. So that is 4 root 13. This is 90 degrees here. So based on this, we can write all these ratios, right? First, let's do that. Let me zoom out so you can see the whole thing. Sin alpha will be opposite. For alpha, the opposite is 8 there. Okay, so that will be 8 over 4 root 13, which you would write as 2 over under root 13. Right? Whereas sin beta, for beta, the opposite is 12. Okay, so that is 12 over 4 root 13. That will be 3 over under root 13. Okay, but you would convert that to a rational denominator, so that will be 2 root 13 over 13, and this would be 3 root 13 over 13. Okay, and now what is sine alpha will be cos beta, and what is sine beta is cos alpha, because if you look at cos, for cos alpha the adjacent is that 12, right? So I'm writing that here. Okay, cos beta is sine alpha, cos alpha is sine beta. Okay, so I already have that values, I can reuse them here. This was supposed to be 13, not beta. Sine beta equals, and we know the sine beta, that is 3 root 13 over 13, and sine alpha was 2 root 13 or 13. So you can reuse them like that. Okay, This is an interesting property in right triangle, you know. And when it comes to tan, that is the ratio of sine and cos. So you have 2 root 13 over 13 and 3 root 13 over 13, right? These two values basically taking their ratio. So obviously it is 2 over 3, or actually simply you can just look at the opposite by adjacent, 8 over 12, which will be 2 over 3. Tan beta will be, of course, then 3 over 2. Okay. Solving. Okay, we did not do the solving part. Let's do the solving. The last, we have the three sides of the triangle. We know one angle which is 90-degree. We need to find two more angles. Okay. So as far as solving is concerned, we need to find alpha and beta and we will be done. And which ones can you use? Use any of the known trig values here. Like tan alpha is 2 over 3. Right? So alpha is tan inverse of 2 over 3. And for beta, you can do 90 minus alpha, or do the other one, tan inverse of 3 over 2. And you will have your answers. Okay, let us do that on a calculator. Tan inverse of 2 over 3. Okay, tan inverse, I need to be in degree mode, 2 divided by 3. And that is 33.69. Okay, that is alpha. And if I were to now find beta, that would have to be 33.69. So the remaining angle. Okay. Let's predict it here and we will go back and check on the calculator. Out of 90-degree, what remains should be 57, right? Less than that, 56.31 degree, approximately. Actually, let me remove this and put approx symbol. Okay. And let's see that. Tan inverse of 3 divided by 2. 56.31. If you round up, it will be 56.31, right? Okay. Before we move on, just one more thing I'll tell here. Some basic knowledge is helpful to spot if you made a mistake. Okay. 2 over 3 is less than 1. So the angle should be less than 45 degree. 3 over 2 is more than 1. So the angle should be more than 45 degree. Recall, or if you have made the trig butterfly, the value of tan 45 degree is 1. Okay, when the two sides are equal, the ratio is 1. Anything less than that will have trig value less than 1. Any bigger angle will have trig value more than 1. Okay, here one last. A is 10, C is 12. Nothing else is given. Okay, from the diagram, it looks like that's the 90-degree. We have to go with that. Otherwise, you can't solve. Okay, let's solve the triangle first. Okay. B will be under root c square minus a square, because c is the hypotenuse. So that is under root 144. 12 square is 144. Okay. 10 square is 100. So 100 under root 40, 44, which has 2 out of it, under root 4, and 11 times 4, 44, right? So 2 root 11. That is B. And you can write the ratios just out of that. Okay. Now let's do that and then we will solve the triangle. Sine alpha will be A over C, and that's 10 over 12, 5 over 6. Sine beta will be B over C, or beta, B is the opposite one. And actually, by the way, that is also a common practice, the convention. The sides of the triangles are denoted by ABC, and the opposite angles are angle opposite to A is alpha, angle opposite to B is beta. Usually, okay, not a strict requirement. B over C. B is 2 root 11, C is 12. That is under root 11 over 6. Okay, so like before, I'm going to say cos alpha is sine beta, so that is under root 11 over 6. Cos beta is sine alpha, so that is 5 over 6. Tan alpha would be A over B. For alpha, A is the opposite, right? A over B, and A is 10, so 10 over 2 under root 11. And now B is in the denominator, so I need to rationalize it. That is 5 over root 11, which you can write as 5 root 11 over 11. And tan beta is B over A. Okay, the opposite. I'm going to take this one to do the reciprocal. That will be under root 11 over 4. Okay. Solving. We already have the gamma there to be 90 degree. We need to just find the three angles, right? The three sides have been determined. Alpha would be, use the simplest one here. Sine alpha is 5 over 6. So sine inverse 5 over 6. And beta will be, which is easier. None of them seems to be easier. So I'm just going to go with tan. Okay, tan inverse under root 11 over 5. Okay, and these are going to be approximate values. So let's use the approximate. We'll do that on a calculator. Sine inverse 5 over 6, tan inverse under root 11 over 5. Okay, tan inverse square root 11 divided by 5. Okay, 33.56. I'm going to round up to 2 decimal places. 33.56 degrees. So that is going to be, we did this a second ago, 57.56.44. Sine inverse 5 over 6. Check that here. Sine inverse 5 divided by 6. 56.4. Okay. Everything has to work out, right? That will be our last lesson, for which I'll make one more video. Thank you for your patience. See you.